Hey everybody, thanks for coming. My name is Caleb Harth. Generally, I prefer to keep these brief at the beginning of talks, talk employer, promotion, all that stuff later because you're already here, and I don't need to convince you to come, especially in a single track conference. But we're all here for the same reason anyways. But in this case, I do want to touch on my background because it helps to underline kind of the point of my talk here. So I've been doing Ruby on Rails for over 12 years, and in that time, I've spent about 5 or 6 years each at product companies like Heroku and Square, and at consulting companies, including Thoughtbot and Testable. Currently, I work at Buoy Software, a health tech company focused on building software to facilitate blood plasma donation, including scheduling, payments, donor management, that kind of thing. You can find my blog online where I talk about various concepts like ethics, best practices, testing, that kind of thing. And since the foul place is done, you can find me on the Fediverse at caleb@calebharth.com or just by searching Caleb Harth. That's also my email if you need me for anything else. So, throughout my career, I've had the opportunity to work with dozens of Rails apps, each with their own test suites, and that's given me the chance to see a lot of different ways of writing tests. Often, you see that one little let and it would just be so easy to use. That before would really be helpful. They always seem like a good idea at the time, but I've seen that type of coding grow organically into spider webs of complexity that's difficult not only for the new guy on the team, new person on the team to grasp, but also for grizzled veterans to reason about. Let defines a memoized helper method. Give it a name and a block to execute, and it will execute that block once, store the result, and then return that stored value. On subsequent calls, it will return that stored value. If you dig into the definition, it's almost exactly the same as a plain old Ruby method. The let method can be referenced by other lets. And depending on the nesting, that reference may be to a different method in different specs. Subject can also reference let methods. Speaking of subject, they're basically just a let block with special semantics, since there are methods like it's expected to that use the subject implicitly. You can also give subjects other names while maintaining those same semantics, but effectively subject is just a let named subject. A before block is executed before each spec that's in scope for, which is to say that any describe or context block that contains both the spec and the before block will execute that block. So I'm going to use before as a stand-in as well for around and after. They're all the same thing, just at different points in the life cycle of the spec. It can reference let variables or any other variable that would be in scope for a test, including let and subject methods. Can everybody read this okay? In the back, you're good? Just kidding. I ran this through some scripts that converted every 4 lines and 2 characters into a single Braille character with a dot wherever there's a non-white space character. And then I ran it through some more scripts that applied different brightnesses to the text, depending on how many of those lines apply to what I'm talking about at the current moment. So taking a look at an extreme but real example of one reason that let and subject are problematic. This is a 4,500 line unit test for the God object of an app I once worked on before I started on a project to begin to refactor it. It makes heavy use of let, not just for the main model, but also for many other method names. In 4,500 lines, there are 531 let definitions across 131 method names. 78 of those are overwritten in different describer context blocks. 9 of those are redefined at least 10 times with a maximum number of redefinitions of 69. Nice. In addition to that, there are 87 times that subject is defined. Almost every one of those cases is a different type of subject from the original definition, which is to say that it is not the model under test, the system under test that's being returned from subject. It's a collaborator or a submethod that's being returned instead of, for those different specs. Almost 14% of this file is dedicated just to let and subject lines, not including multi-line blocks where those values are actually defined. Much of the structure is front-loaded in this spec, as you can see there. It's in place to support an extremely complex general fixture, which is one of the root causes of obscure test, which simply means that a test is difficult to understand at a glance. You can't imagine why. General fixture is the term that Gerard Messeros used in X-unit test patterns to describe when a test builds a larger fixture than is necessary to verify the functionality in question. In Ruby and RSpec terms, there are 31 let definitions that are in place to parameterize the default subject instance. This is all setup that isn't needed for most tests, but because one or two it or describe blocks needed to reference some behavior, all specs in this file now evaluate this code on every run, unless they define their own simpler subject. It's harder to visualize, but the majority of these methods are also defined such that they are only used in a single spec. They'd be so much simpler and clearer if they were inlined into the it blocks. Needless to say, it's quite difficult to reason about a given let or subject method, where it's defined, what it's contained, or even where to find it. It isn't uncommon in this file for a let or subject to be defined several hundred lines away in several different block scopes from where it's being referenced in a given spec. So I wanted to share all of this because as we move into a more contrived, more manageable example for the amount of time we have to refactor, we should know that real-world test suites look like this. You probably have seen them, you might maintain one. In my experience, this is what RSpec suites trend toward over time. Our goal should be to have manageable, understandable, and maintainable test suites that we enjoy making changes in. So we have a situation where we're defining a method, which let and subject both are, with extra steps. And it's hard to track because it's done through macros and they're intentionally easy to redefine. Beyond the navigation issue, these methods construct themselves by referencing other let variables. And across different specs, these delegations are referenced in different methods. While the code seems to be doing the same thing, it could be going through entirely different code paths, depending on which of these are actually being evaluated. Finally, especially in the case of subject, it's common for the type of thing being returned to change into a different describer context block. So, what are our options for refactoring our way out of this? Perhaps the simplest option is to replace let with an instance variable. For example, we could replace let book with at book. While this technically checks the avoid let box and may be slightly more performant than a memoized lookup method, it maintains a lot of the same issues. Specifically that it's likely to be overridden or defined differently in different contexts. So there's little chance of finding the correct definition for a given text of a spec of even moderate complexity. Another option would be to change these let and subject definitions to properly define Ruby methods. This involves memoization via instance variable or equals some value of the that needs to be remembered. Doing this improves the odds of automated introspection tools like C-tags or a language server finding the correct definition, but it does not help with the second part, which is that it's still very easy to override these. These methods may be delegating to various different things, depending on how spaghetti your code is, and different specs depending on the various nesting and context blocks. The third, and the one that I recommend here, is the inline method refactor. This is a refactoring tool originally named by Martin Fowler in refactoring, improving the design of existing code. And it's pretty straightforward. Instead of pulling these variables into a letter subject, put them into the test. But Caleb, that's not dry. You're repeating yourself, and we don't repeat ourselves. This is Ruby. This points to a common oversimplification of don't repeat yourself. Andy Hunt and Dave Thomas in The Pragmatic Programmer stated the dry principle as every piece of knowledge must have a single, unambiguous, authoritative representation within a system. The goal of dry is to avoid duplication of knowledge, not duplication of code. Now, it turns out that duplication of knowledge tends to also reduce code repetition, but that's a side effect and not the primary purpose of dry. I think that it's often simplified to new programmers, it was to me, when they're learning about dry, that it's just deduplicate code and you won't be repeating yourself. But even if this helps with deduplication of knowledge, it leads to premature extractions of code that then need to be parameterized to support different multiple use cases, which is what happened with that general fixture in the heavily parameterized general fixture that we saw at the beginning. The default version of subject, which is defined as described class.new, or more concretely in our example, book.new, is really more of an indirection than a consolidation of knowledge. Book.new is already a method. Wrapping it in subject, it doesn't dry anything. But even if it did, in the case of tests, I would argue that knowledge deduplication is not necessarily a good goal. I've called these tests specs because colloquially I find that generally that's how we talk about them, but RSpec calls them examples. And I'm glad that it does, because example points out that the code that you're writing should look like the code that you're executing. It should be an example of how to use this code. As David Brian Copeland wrote in November of 2022, RSpec examples are, well, examples. The article's thesis is that avoiding predicate matchers, such as expect order not to be sent, should be avoided in favor of expect order.sent to equal false, which is a good point. I have to say that because unlike Gerard Messeros, Martin Fowler, or to a lesser extent Dave Thomas, David might actually see this recording, so I should be nice. But I also do agree with it. To take his point even further, it's desirable for each example to be self-contained as an example of how to reproduce behavior. Following that pattern, given any individual RSpec example in isolation, we have all the knowledge needed to reproduce the behavior being specified in the example in our code. Drying tests reduces the utility of each example by relying on shared utility methods, or worse, unshared utility methods, that convolute what is actually happening in the tests. If you can't look at an example and understand what's being tested, how the system under test is intended to be used, and to be confident that it works, then the example is not really living up to its full potential as living documentation. So my advice is to write everything twice, or hopefully more than twice. Embrace that there may be a lot of setup that needs to be duplicated between examples, because these examples are documentation. Doing that setup inline allows you to write only what you need for each test, not building these general fixtures, and not needing to support multiple things. But it also shows the difficulty of your code to be used by surfacing these extra collaborators, the arguments that are needed to initialize a class, and any other setup that's required to exist in an environment before your code can actually run. Complexity introduced in the name of decreased code repetition does not make your specs better, and it's not a worthwhile trade-off just to write less things. If you're testing the return value of a unit-tested method on another class, this is not the slide that I wanted. If your test setup includes many collaborators, try refactoring to avoid a complicated setup by reducing its fan-in or the number of collaborators it works on. If you're testing that a unit test is, if your unit test is testing the return value of some other class, you can mock out that collaborator and rely on its unit tests, and then you can write a single integration test that proves that those things work together correctly. Since Mastodon is the new cool place to be and is a Rails app, I thought we could take a look at a portion of one of its tests for this refactoring example. This is the full spec for the mute bang method, split into 3 columns to better fit on the slide, and it's a test of the mute functionality of an account. If you'd like to follow along, it lives, preferably later, keep your laptops closed, in spec models concerns account interaction spec. I know that you can't read this text. It's okay. I'll be talking through it, and we're going to use bolding and color and animations to help draw attention to what matters as I'm talking. So we can see that the spec overrides the default subject and that it's used 9 times in about 100 lines of code. Subject is a good place to start for this type of refactoring because when it's used, it's referenced in most examples in the suite. So it's a high-value refactor. As I mentioned, we can use the inline method to take the body of the subject definition and place it directly in place of the body of each spec. Thanks to scoping, even though the subject definition referenced let variables, account, target account, arg notifications, the code will continue to run here and have access to those methods. One thing to look at is that these tests all have a very similar and non-flat structure. This can be an indication that you may be testing more than one thing. So let's take a look at a closer look in case there's some overlap. This line shows up in each of those 9 tests that we modified. It looks like these are using an expect to change block to send the mute message and then checking the return type. This is an optional refactor, unrelated to letter subject, but we can take this opportunity to reduce that duplication by removing that type check. Zooming back out, we can run these tests to ensure that they pass. I did, they do, don't worry about it. Then we can continue to inline let methods. Hide notification and arg notifications are similarly named because they're used in keyword arguments of similar names. So they're adding confusion by existing as opposed to being inline in the calls. So let's just inline them. Doing that means we no longer need these context blocks that were being used to define them. So we can flatten them as well and take their meaningful semantic text in their description into the it descriptions. Now you may be getting excited, this test is getting shorter. Don't worry. Now we can inline this mute into each spec as well. And because it's referenced in a before block, we can go ahead and inline that now as well. Now we're moving into some actual code in the specs that was obfuscated before. The hide notifications flag was previously being set in context blocks in each spec, so it's easy to tell, so it was difficult to tell what the value actually was. It's now much easier. You can just look at whether we're saying true or false. And you don't need to scan for this hide notifications name, search backwards, hope that you find the right definition, and then check to see whether it's true or false there. I'm going to fast forward a bit, and I'm going to inline two things at once, account and target account. They seem to be coming from nowhere here because, like the original obfuscated example I showed, these let methods are defined hundreds of lines away from where they're being used. So it's difficult, so we really had no idea what they were. This particular file happens to be about 650 lines, and those uses those lets all over, but luckily I didn't have to it doesn't override them, so I didn't need to do too much work to figure out what the actual values should be. It does beg the question why they existed in the first place. We're able to inline the definitions in place of method calls in some places, and in others we use local variables to replace the method definitions so that we can make assertions on those same values later. Let's take a look at one of those refactored specs. This is an example from before we made any changes. It's extremely terse, tells us almost nothing about what we're testing. We can kind of tell that we're making expectations about some kind of a subject, but recall that this is a unit test for a concern called account interactions, so we can't even have a class that we can guess based on that what this subject is, based on described class.new. The innermost expectation is that it's returning a mute, but where that comes from, we really have no idea. To find that, we'd need to scroll up in this file about 55 lines, well over what fits on most screens. We're checking that the mute doesn't change its hide notifications setting. Where the mute is defined, what its context is, or why it's related to the subject are completely opaque to us at this point. We also know that the B kind of expectation is checking a return type, that expectation is duplicated 9 times in this file and is unrelated to the purpose of this example, which is to test the hide notifications flag. It's almost helpful in these specs pre-refactor because there's so little context that the type checking kind of helps us to understand something of what's going on. By the way, this code never returns anything but a mute from this method. Finally, we have no hint that there's code being executed as part of this test that's run in a before block. After our refactor, the test is bigger. But it's also understandable in isolation. Every piece of context, every piece of work, every hidden step that was previously elsewhere in this file is now here so that we can read through it and understand what is happening. For a lot of the same reasons as let, I recommend against using before in most cases. That said, at the global level, it does make a lot of sense for things like database cleaner to run all tests and transactions, webmock to disable outbound network connections, and similar global level things that you need to do. The smell comes when doing things scoped to describe or context blocks or even to a spec file. At the risk of repeating myself, it makes sense to repeat yourself in order to have understandable tests. Avoid hiding excessive setup in some blocks so that things seem simpler than they are. What's worse about let than before is that it's additive rather than replacive. Whereas redefining let or subject will not execute the code that would have been defined in a different block before blocks combine. This can lead to a lot of setup code happening outside the scope of the test that you're running. It can be difficult to track, and it can be difficult to track down what all of it is. Shared examples, shared context, behaves like, and similar tools in RSpec have all the same problems as letter before, compounded by the fact that they're being used in an indirect way and probably multiple times. They have the additional problem that they explode this complexity because of that reuse. Each example, block, subject, let, are all being used each time they're included which means that a single test can be executed a dozen times or more in different contexts depending on how many places it's referenced from. These hide complexities in the name of decreased repetition and often require a lot of their own setup to be used. Again, I'd recommend moving the important specs from each class inline into the main specs for those files rather than trying to extract using these tools. And for things like a module or a concern, rather than testing that every single class that includes these modules behaves as if it does, try to test it directly or possibly create a simple implementation that can also be used later as a reference for what's needed to use this module in the first place. So in summary, use RSpec, but use the good parts. Don't use let, don't use before, don't use shared anything. Once again, I've been Caleb Harth. Thank you so much for coming to my talk. If you'd like to discuss RSpec, Buoy, Mastodon, or Dungeons & Dragons, please do come find me in the hallway. I'd also like to thank my employer, Buoy, for sending me to the inaugural BlueRidgeRuby. We're very interested in talking to you if you're a senior full-stack developer looking for a new, fully remote job where you can make a positive difference in the world. You can find me in the hallway or go directly to careers.buoysoftware.com to learn more. And don't make the mistake I did. The U comes before the L. Thank you very much.